What is up, YouTube? Mr. King coming at you live from the 209. Here are the questions for the day. Please pause the video now and answer them. Next, today you should be able to apply. We're going to go into some practice problems and apply your knowledge of the law of conservation for some practice problems. But we are going to be taking notes today. So go to Friday, Conservation of Mass Notes, put your name on it. Okay. Next, some review. So remember, atoms look like this in real life. This is a hydrogen atom, but most of the time you'll see these drawings of atoms. And atoms make up everything. Everything. You, me, your phone, the air you breathe, is even oxygen atoms. So yesterday I taught you about the law of conservation of energy, which is that energy can't be created or destroyed, only changed around. The law of conservation of mass, same thing, except now we're talking about atoms or matter. Matter is just anything that has mass, takes up space. And that counts as air. A lot of people think air is nothing. Air takes up space too. You're breathing it in. Air is matter. Okay. Atoms, those also can't be created or destroyed, only changed. You know, like molecules have a bunch of atoms. You can change the atoms around, you can move them, but can't destroy them. All the atoms in the universe that started are the same they have today. Put that in your notes. There is one exception that I want to talk about. It's nuclear bombs. Nuclear bombs, a lot of people say there's always an exception to rules. Nuclear bombs are the exception for this one. Nuclear bombs will destroy atoms. They'll convert the atoms into energy. Yep. So we're going to practice the law of conservation. Here's a little analogy for you. A lot of times atoms are like Legos. So think about like an individual brick, very hard to just break with your hands. And there are different types of Legos, just like there are different types of atoms or elements. And when you combine the atoms together, you get like a set, and you can move the set around. And it's much easier to destroy like a Lego set versus like an individual brick, just like atoms. It's a lot easier to destroy like a bunch of atoms, like in molecules, but it's a lot harder to destroy like one atom. And now it's your turn. I want you to come up with something yourself. Come up with your own analogy of something that is very hard to destroy or create, but very easy to move around. I'll give you a hint. Come up with something that's used for building a lot, like building stuff up or stuff that we use to change it the way we like. And then put it right here in the second box. Okay. Next, so remember, if atoms, you can't create them out of nothing. The atoms have to come from somewhere. Then how are babies born? Like, how do we get like a living being out of nothing? You should know it doesn't come from nothing. The baby is getting their atoms from somewhere. Try and think, where would the baby get their atoms from? Based on the picture, hopefully you took the hint that the mom is actually giving the baby some of her atoms. That's why moms have to eat so much, and that's why they lose so much energy, is because the baby is taking away some of their atoms from their food and their body to build the baby up. The dad doesn't do much. The dad only gives off the sperm, but the mom is the one that's giving all of her atoms and her energy to the baby so that baby can be born. That's in your notes. Please write that down. Next one. If atoms can't be destroyed, then what happens to our trash? What happens to all the atoms that we're throwing away? If you've seen Toy Story 3, you might know one of them. So in Toy Story 3, they go in an incinerator. Spoiler alert. Where they literally just burn the trash. And you may think, okay, good, all the trash is going away. No, it's going up into the air and it's going to be polluting your lungs. That's why burning trash is bad. That's why you try and reduce, reuse, and recycle. So one option is they burn the trash. The second one is they dig a big hole in the ground and put it in something called a landfill. Yep. The other option is they don't get rid of the atoms. You can't get rid of atoms. They're either burning it or they're burying them. So I'll also put that in your notes here. Okay. Next, your body. If atoms can't be created or destroyed, then what happens to bodies when they die? Like this rabbit here. If this rabbit dies in the forest, what is going to happen to the atoms in its body? For this one, it really depends on how you die. So like if you're like this rabbit and die in a forest, eventually the atoms in the body will decay. They'll either go up in the air as they erode away, or this rabbit, the body will get eaten by worms or like a vulture or worms. So like if you're in the ground, worms will use the body to give your atoms back to the plants. So it's always cycled. The point of that was atoms are always cycling and moving around. Even when something dies, the atoms get moved around and moved around. The rabbit's body will go to the soil, which go to the plants, which could end up back in our mouths when we eat the plants. So that's all the cycle. Next one, let's say I weigh a marshmallow. I weigh a marshmallow and it's 60 grams, but I accidentally burn the marshmallow and now it weighs 46 grams. Try and think, where did the rest of the marshmallow go? Hopefully you notice it didn't disappear. The marshmallow went into the air. That's where the marshmallow went. It just went into the air in the fire. But how much of it went into the air? You should know from the law of conservation that mass just doesn't go away. So to figure out how much went into the air, you take how much went in, 60 grams, and then 46 grams went out. So you take 60 minus 46, and that's how many grams went into the air. 14 grams of that marshmallow. Here's another problem. This one's going to be trickier, and it's also in your notes. Right here. Let's say if I'm making chocolate milk. I'm making chocolate milk and I start with 25 grams of chocolate syrup in a bottle. And then I add 100 grams of milk. After I make the chocolate milk, I notice now that there are 5 grams of chocolate, 5 grams still left in the bottle. So now my question for you is, how much chocolate is actually made? Pause the video now, try and figure it out in your notes yourself. Hint, figure out how much milk and chocolate went in and subtract how much was left behind. I'm going to do that thing. Since I said you start with 25 grams of chocolate, I know I'm adding 25 in, and then I told you 100 grams of milk, so plus 100. But I told you didn't get all 25 of the grams of chocolate in. 5 of the grams are still left in the bottle. So we'll take 25 plus 100 minus 5, because those 5 of the chocolate grams did not go in. So you're going to end up with 120 grams of chocolate milk. That's how much chocolate milk you'll get total. Because you took how much chocolate was there, but some of the chocolate got left behind. So you subtract 5 and then take how much milk you added. That's the law of conservation of energy and mass. Nothing is wasted. It all goes somewhere. Okay. Here's the summary of how I did it. Next, my question for you. Let's say I'm mixing salt and water. Salt and water. I use 20 grams of salt and 85 grams of water. 25 grams of salt, 20 grams of salt, 85 grams of water. How much salt water did I make? How heavy is it? This problem is a little easier. What you do is an addition problem. You take what came in, 20 grams of salt, 85 grams of water, add them together, so then you end up with 105 grams of salt water. All right, this next one is also on your notes. This one is similar to the one on the test. Let's say you're a scientist trying to make a table salt. Table salt is NaCl, sodium chloride, and you use this formula. Sodium plus chloride equals sodium chloride. Use 25 grams of sodium and 47 grams of chlorine. But when you're mixing that, you notice that 7 grams of the chlorine did not mix in or did not react. So now try and figure out how much of that salt was actually made. How much of the salt did you make? This one is similar to the chocolate milk one. Pause the video now and try and figure it out. So take my hint, figure out how much sodium and chlorine went in, and subtract how much was left behind. So 25 grams of sodium went in, and then 47 grams of chlorine went in, but I said 7 grams of the chlorine did not mix or did not react with the sodium. So you'll take 25 plus 47 minus 7. And I know 47 minus 7 is 40, plus 25, so that's 65 grams. So how much sodium chloride did it make? 65 grams of salt. That's how much I made. That's how you do it? Okay. Last thing, in your summary, tell me, what did you learn today? And where do the atoms go when something dies? That is last thing. Write the summary and then turn it in when you're all done and take the attendance survey for the day. Thank you so much, everyone, for staying with me the whole time. Bye.